Welcome. My name is Patricia Cohen. I cover the global economy for the New York Times. And the subject I think that I have been covering more than any other in the past 6 months, certainly since Russia invaded Ukraine, has been energy and the increasing cost of energy, the supply, and looking forward to perhaps a cold winter, particularly in Europe. Probably all of you are seeing how gas prices and energy prices are increasing for yourselves in your own bills. But fortunately, we have Marius Soflete with us today, and he's focusing on something that I feel is really not getting enough attention here. We're all looking at how to increase the supply, whether of dirty fuels or even clean ones, but no one is, or few people are looking enough at how to decrease the amount that we need by thinking differently, by constructing the houses we live in a different way. So, Marius, maybe you could take us through a little bit in terms of your idea of how we should be housing ourselves and how you came up with it.
Hello, everybody. It's a pleasure for me to be here. I'm Marius Soflete. I'm a structural engineer and a passive house designer. And in the last years, I've managed to design and build the first passive houses in this part of Europe. And this concept is a very energy efficient concept of applied to housing.
Right. So tell us what a passive house is, because that was not a term I was familiar with, and maybe people in the audience are not that familiar with it either.
It's a house that uses very little energy to be maintained and to function, because for example, during the winter, we need a lot of energy to warm up the houses. We have this instinct now that when it's cold, we just push a button and then something starts there, like a machine starts to generate heat, and then our houses are heated. A passive house, it's a house that uses only solar energy to be heated. So you don't need extra tools or machines or building services to heat the house, and you don't need to consume fossil fuels or other kind of energy. Even though if you choose to use traditional fuels, you will need only 10% of them compared with traditional houses. So to be much more easier to explain, all of us are used to live, or we have been born in old houses. I've called them houses that were done 30 years ago, because in this part of Europe we had an explosion of new buildings 30 years ago after the communist period went down. But they were very big houses done as our parents or our grandparents know how to build. And for these houses, we used a lot of energy to heat them. For example, a traditional 200 square meter house would need about 4,000 cubic meters of natural gas each year to be heated. Now just imagine, add these 30 years since then, how much gas this kind of houses burned to be able to maintain them warm enough in the winter. But also there's another problem that using this kind of fossil fuels, we generate a lot of carbon dioxide that we throw into the atmosphere. Mm-hmm. Also, this kind of houses thrown up about 10 tons of CO2 in atmosphere. And now we can see all these climate changes that it's happening around us. So actually the building sector, it's responsible for more than 40% of the CO2 emissions on the entire planet.
That's incredible. I didn't realize myself that it was that high.
Exactly. So we thought that cars, traffic, and airplanes generate a lot of CO2, but no. Actually, staying in our houses during the winter and heating up the houses is the most it creates the most damages to the natural environment that we live in. Mm-hmm. So we have to reduce. So actually, all the principles that are in the passive house is to reduce the gas consumption and the CO2 emissions. It's like we have now the transition to electrical cars. It will take some time, but now we see that they are growing up as an market demand. It will be the same with the houses. We could say that a passive house is identical with an electrical car. Then, for example, in Europe in 2005, we had a lot of new rules that were given by the European Union, because European Union was forecasting that something will happen with energy demand. It happened today. It's at our boundaries, no? So we started to build better 15 years ago. That's why I've called them houses built in 2005. That actually are the houses that each of us are living now in. By having some measures integrated in the buildings, we've managed to reduce the energy consumption. So instead of using 4,000 cubic meters of natural gas, now we are using 1,500 cubic meters. But still, we have about 4 tons of CO2 in atmosphere.
Okay, let me just stop you there for a moment and talk about, you said we took steps to decrease our use of energy. What are those steps? How do you do that?
Well, we are doing this by building better, by using much more performant materials, better windows, better insulation. We started to increase the insulation of the houses because actually we should see the houses that we live in like an outer shell. Their goal is actually to maintain our comfort condition. One of their goals, because usually a house has multiple goals. So when it's very cold outside, we are staying in the house, no? We are warming it up, but that entire heat, it goes out.
Right. I mean, I don't know if people understand just how drafty your house is, even that heat is escaping all the time and cold's coming in through the windows. And one of the things that I actually hadn't heard about, I've heard of double pane windows, but you talked about triple pane windows, which I don't know any houses that have that. But explain what happens. You know, how the kind of cold gets trapped
in those windows. So just imagine the house like an extension of your body. It's very cold outside. You go to the mountains to ski, or you go outside to play with the snow, and you have very good and very thick clothes on you. You have a big jacket on you. You have big pants, well insulated. You have big shoes. You have something that you put around your neck. All those materials, they just preserve the heat of your body. It's the same with the house. So we have to put a lot of good insulation on our houses to preserve the heat that we have inside it.
Right. Or like layers.
Like layers exactly.
Of clothing.
Put multiple layers. It's the same with the walls, the roof, the foundations, everything. They need to have very good insulation and very good materials. It's like, just a second, I'll go a little bit forward with this. Imagine that your house is a super house, like a hero, no? But in order to be a hero and to fight with energy demand, it needs to be very well insulated so that the energy remains trapped inside. If you have this, then you will use less and less energy to make the house warm during the winter. Why do I say during the winter? Because, for example, here, we have to warm our houses about 4 to 6 months per year due to the cold region that we are in. Actually, the entire Europe, except probably Spain and Italy, need to warm up the houses during the winter. So that's an enormous quantity of energy that we are using each winter in our houses. Therefore, we have to make the small steps like insulating better the houses, paying attention to all details when we build, like what kind of windows do we use, what kind of materials do we use, even the entrance doors, for example, how performant should they be? Each kind of these details that are designed by architects, engineers, and that builders should care of.
Now, is that house much more expensive to build than a house today, the way a house is built today?
Depends with what are we comparing it. Because if we compare it how we are used to build now, yes, it will be expensive. It's like the car. An electrical car today, it's expensive than a normal car. But if we look also to the energy consumption and the bills that we have to pay in time,
in the long run,
then we have to do this calculation considering 20 years, 30 years, or 40 years of using that house. And here we have a lot of problems in the economy because we have inflation, we have different kind of access to resources. We are seeing, for example, that the price of gas is going up. It goes up, down, and from time to time, but the entire economy changes from year to year. And I also have something to show you, is that, for example, the average natural gas price is increasing continuously. This is a graph that shows us how many dollars we have to spend to buy 1,000 cubic meter of gas. So today we have to spend more than $500 to buy those 1,000 cubic meter of gas. And in the same time, how much can we afford from an average salary? Also, it depends from one year to another.
Right, but it's eating up a bigger proportion of your income than it was before.
Exactly, because actually, at the entire European Union and in entire Europe, the salaries are not growing as faster as all the prices are going.
Right.
And on this graph, I've tried to show how much gas can we buy from one average yearly salary income in this part of Europe. So we had some spikes, like we had a period, it's just the period when the Nord Stream 1 and Nord Stream 2 were done in Europe in about 2000. So then we had a lot of access to natural gas, so it was cheap, we could buy a lot. But now we can buy very the power of buying, it's very down.
Right.
Because the gas price is going down, the salaries are going down.
And I will say that in terms of all of the experts that I've talked to, really feel that this kind of period of cheap gas that we've been used to previously is over.
Exactly.
And that, during this long period of transition, which is going to take several years, we're going to see these consistently high fuel prices. That's going to be eating into incomes more and more. So in a way, this is another way to kind of get at both the income issue and the energy issue.
But it's another problem. Even though we will still have access to resources, they will be used in the industries. They will be used in places that it's very needed to. So, because we can warm up our houses by making fire in the chimneys, no? But we cannot produce steel or concrete without having gas as a fuel. Okay. So even though we will have some access, that part will be directed with, how should I say, it will be much more important to be used in the industries. That means that, again, for end users like us, like each one of us that we are here or we are staying into a building, it will be harder and harder to have access on these resources.
So is it possible to convert a house that's already built and make it more energy efficient? And how would you do that?
Well, you just have to go here at the unfinished headquarters. It was the same. It was a very old building when I saw it the first time, because I've worked with Christy on this project. When I saw it, I said, okay, let's take it down and build a new house. But Christy wanted to save that building. Right. So we've made some steps, like we've insulated the roof with better insulation and thicker insulation. We've changed the windows. We've put some insulation on the ground. So we've managed to reduce the consumption that house had before with 60%. So all these steps actually can be implemented in each kind of building, even in schools, hospitals, office buildings, and so on.
So do you think that there's something like, is there something that if you're sitting in this audience that you could do in your own home? Or are we really talking about to have a significant impact? We really need governments to kind of take this on, and the building industry and the construction industry to come up with a new economic model, perhaps, in terms of how to build.
Well, we have to work as a team. So the first step, it's each one of us should do something. First of all, lower the temperature that you're staying in. You can stay at 20 degrees. It's very comfortable. It takes about 2 weeks to adapt, but it's the first step, because with each grade that you're putting, each percent that you're adding to
each degree
that you're adding to the heat of your room, it puts much more pressure on the building system to warm it. So it consumes more. This is the first step that you can do. Put an extra cloth on you. You will get used to it. Then the second thing, look on your windows. Mostly the windows of the houses are the most weaker part in this shield, in this thermal shield. So they can be improved, like repair them, put some rubber bands around them, put some clothes down if you have an old wooden windows. Or if you can, change them. Because adding new windows, like triple glazed, they will be buybacked in about 5 years. So actually, the money that you spend on gas will buy the new windows in 5 years.
Right.
Then
So over a period of time, over those 5 years, you'll essentially make back the money that you spent more upfront by savings that you would get.
That you have. And this is an example on average dimension buildings. I'm not speaking about big houses or schools and so on. So these are 2 steps. Then the third step, it's a little bit complicated, but it could include some repairings that could be done on the building, like air tightness. You could see where the hot air is going out from the house and fill up those holes. Or, for example, a lot of old houses like this have chimneys. So there actually you have like a tube that is getting out the warm air from the house and it's bringing cold air. So that cold air, you need to heat it up continuously. So these are some steps that you can do in your house by not being an architect or engineer or a builder. Then indeed, further measurements could be taken, but that means that it's not quite comfortable to do them during the winter because to build up again or to have builders in your house, it's not comfortable.
Yes. So let me just step back for a second. And, I was thinking when you were saying like turn down the thermostat. So, in public opinion polls, when you look at them and you have people say that there's a lot of support for backing Ukraine. And then you ask people, the same public opinion polls, okay, I think one was in Germany, are you willing to have driverless Sundays so that nobody uses a car on Sunday? Are you willing to lower the speed limit to save fuel? Are you willing to lower your thermostat? And suddenly you have a very different response. And I guess, how do we summon the political will? Because people abstractly support these things, but when it comes down to actually making these little, even relatively small sacrifices, we see there's a lot of resistance to that.
Yes, but still we are living a period that is the much comfortable period for the humankind. We are getting very lazy. we have a very long life expectancy, and actually we are doing a lot of how should I say, we are not living sustainable anymore because we are losing a lot of energy. We are losing a lot of food, for example. We are losing a lot of fuel because we don't really need it, actually, because we have a very comfortable lifestyle. And we can adjust this balance to be much more, to think much more economically, to be much more sustainable in every aspect of our life. How much food do we buy? Because, for example, 30-40% of the food, we are just throwing it out. No?
I know. I was reading that recently. It's incredible how much food waste there is.
We have cars with big engines that consume a lot. Actually, we could use smaller cars with smaller engines to go from one point to another. We could use public transport and so on. So these are steps that they won't affect too much our comfort condition. It's an extra comfort. So having these steps, it will help a lot, because otherwise we don't have to choose. Now we can still choose to do some steps. It may come a period when we won't have to choose and to take measurements.
And do you think that governments are, effectively getting this message out? Because we're in a period now where we see a lot of far right and extreme populist movements that are gaining support by taking a very different approach to this. Like, what is the kind of message that can more effectively combat that and really mobilize people? Because obviously, anytime when you're in economic tough times, whoever kind of promises to get you out of it the easiest way, it's attractive. What's missing in our message or the left's message that it's not more effective, that to be motivated to do the kinds of things that you're talking about?
Well, we are used as human beings to be ruled. No? We need a ruler. We need somebody to say us what to do or where to go or somebody to protect us. Actually, the role of a government in a country is to protect the people of its country. But still, that government is ruled by other people who could have personal interest. So what can we do? It's to be as independent as possible. To be independent, for example, with our energy sources. Because today, everybody is expecting the government to make actions, but they are limited also. Even though we would have people that are very well intended, they wouldn't have enough power. For example, now the Romanian government is speaking about having a limit to the price of energy, because they will pay the extra price from the national funds, but they will finish at one level. No? They won't be able to maintain the same price for years. They can say, okay, we can help you this winter. You will have then the next summer, but then you have to prepare yourselves to be able to go up to the other winter.
So let me ask you, and I realize I'm pushing you outside of housing here, but obviously, these are issues you've thought a lot about in terms of energy and how to make changes on a wider level. I live in Britain now, and my energy bill is supposed to double next year. And, there's this debate between some economists who say, don't cap prices because high prices are the way that you discourage people from using more.
Exactly.
At the same time, and that makes sense. On the other hand, you've got people who are afraid they're not going to be able to literally heat their homes this winter. And so, how do we find that balance between kind of protecting the public, particularly poor and vulnerable people who can't afford things, but yet at the same time discouraging more use of fossil fuels?
So probably instead of helping people to pay their bills, personally, I would help people to improve their buildings, because it's about the same money, speaking in 3 or 4 years timestamp. So those kind of measurements should be much more put it in front. So instead of giving you money to pay your gas bill, I would help you to put another heating system. It's the same money. So I would help you to put new windows, encourage you to take measurements that in the future will not put pressure anymore on the government to have this kind of extra money from the national budget that they have to put in.
And do you find, let's just talk about in Romania for the moment, but you were just talking about how you've been giving talks all over and outside of this. Are there people in the government who are responsive to these ideas?
Well, here, to be honest, they're not that responsive. So they had an inertia of understanding things. We could have prevent this kind of crisis by acting much more faster years before. Now,
one of the things I was struck by, and I know you didn't get through all your slides, but the houses, that's at least 20 years old now, or almost 20 years old, that we've had these new standards in effect. And
well, it happened something in the last years. We had some national programs that helped people to improve their houses. So you could access some funds to repair your houses. Now, these days, these funds were blocked to give people the same money to buy energy on this winter. So it was a very bad shift, because we had these programs in the last 3 years, but suddenly the government said, okay, we have some money, we'll block the money from making new buildings into having the energy issues in this winter. So it wasn't a very good shift. Even though in the last 15 years, we had different kind of steps in the laws, in the building codes that pushed all the new building developers to build better and better to this. But unfortunately, a lot of people tried to go outside the law, then sticking into it.
Yes. I know I'd like to actually bring in the audience at some point and have a conversation between everyone here. So if you have questions, think about that, and we can get that to you directly. But let me ask you something in the meantime while people are thinking. You've been working on this issue for more than a couple of decades now. How do you keep from getting discouraged?
To be honest, when I was a child, I've been witness to this kind of crisis. About 25 years ago, in my national city, my national town, which is it's in the mountain. It's a very cold one.
Where is that?
Kovazna. It's nearby Brasov, and we have winters with minus 25 degrees, and everything freezes on you. So we had about 2 years when there were some law changes, and the city heating system went bankrupt. So actually, everybody from the city didn't have access to heating.
Wow.
For 2 years, in time that everybody started to change their heating system and so on. So I've seen 2 winters when people, even though they were doctors, professors, market sellers or so on, started to put wooden chimneys in their houses. And the entire city was very polluted because everybody was burning wood. Mm-hmm. And the entire architecture of the city went down, like it was like in a movie, bad movie.
Right.
So that was my first real impression of how would our world look without energy. So that's why all my studies and everything that I've started to do was into that direction, because I've seen it with my own eyes. And then that's the thing that encourages me to do this, but also the results that we are having. Because, for example, we've managed to design and build the biggest passive house office building in Romania. It has 2,500 square meters. It's used by more than 200 people. And in the last 2 years, they had less than €1 per square meter per year costs of heating, cooling, and ventilating the building.
So tell me more about this building.
Well, it's a big office building. It was
because actually one of the things when you were talking before, I was wondering, could you do this in an apartment house as opposed to, an individual house?
It's a building that was done under the passive house principles. So we had a very good insulation on it, about 30 centimeters of all layers, very good windows, and heat recovery ventilation system, and different kind of better materials. So we've managed to preserve the entire energy of the house. We are using also the energy given by the computers, because, for example, when you use a computer, it's heating it. It has heat. No, we are taking that heat back and giving it to the building.
How do you do that? I always think about that when I'm working with my laptop on my lap and it's really hot. And
yes.
How do you harness that energy?
So the principle is this. I'll have to show it on the graph. So instead of opening the windows in the winter, you use a ventilation system that has heating recovery. So actually you are using the laptop. That laptop heats the air. That air, you are pulling it out from the building. But first of all, you are taking it through some filters that they take out the heat from that air. Then you have then you have cold air from outside, and you get that cold air to the pipes, and those pipes are warmed with the air from the inside. So actually you pre-warm the cold air that is coming by having back the heat that is stored into the interior air. So if you apply this principle, you can reduce with 80% the energy consumption to heat that air.
It's kind of astonishing. I don't know. I feel like I'm missing something. Like, that sounds so great. Why isn't everyone doing this?
Well, we have to trust me. I'm an engineer, because these are principles that are not really well known. People don't really know about them. And I'm not saying that people like everybody who's using the house. It's also a problem of people who design and build these kind of houses. So it's a lack of knowledge on this. For example, this is why I've started to make courses, public courses, and to have a lot of passive house trainings for people around all over this country, to make people understand all these kind of steps that have to be done in the houses. We also managed to do the first premium passive house in Romania, which was the 10th in the world. It's a house that produces 3 times more energy than it uses. So actually it becomes a sort of a pole into a neighborhood. That house can...
Now, how is that house producing more energy than it's using?
Because, first of all, we've managed to conserve its entire energy and to reduce entire energy consumption. Then we've added some solar panels that are producing 3 times more energy than the house is consuming. But first of all, you have to do these steps to reduce as much as possible the consumption. Because when we use solar energy, sorry, it's here. Here it is.
I made you go out of order with your slides. I'm sorry. It's my fault.
No problem. So this is a graph that shows us how much energy can we produce by using photovoltaic solar systems. So we can produce a lot of energy by summer, but actually we need a lot of energy by winter.
Right.
No, when we need to heat our houses. So actually there's a gap between when can we produce and when do we need it. But we cannot store the solar energy. It's very hard to store it, to put it somewhere and then get it out from there, because we lose a lot. So actually we have to make these 2 gaps become much closer to them. So that's why you have to reduce a lot of energy and then to be able to produce. So this is why this kind of house, it's here. Actually, no, it takes energy from sun. That kilowatt, it means kilowatt hour, how you measure the energy.
Right.
And it's free. It's there, just have to use it. And by having all these kind of principles implemented and using alternative heating system, like a heat pump, for example. Everybody has a heat pump in the house. Do you know what's the heat pump? The fridge, your freezer, no? Because it's cold inside.
I didn't know that. That's good.
Yeah. You just take a bigger freezer, you reverse it, and then you have heating in your house.
But if you can't store the energy, the solar energy from the sun, then how are you supplying it during the cold?
For example,
it's cold and it's not sunny.
Okay, you have sun that produces energy. You take that energy, you use a heat pump, which takes electrical energy, and it converts it into thermal energy. And then that thermal energy, it means that you can you have a small storage device called boiler or inverter. It looks like a barrel, that's well insulated, and you heat the water inside, and you can heat and store hot water for 2 or 3 days. So with 4 hours per day of sun, you can produce local hot water that it's enough for you for 3 days to make showers and to heat your house. But only if you have a very good thermal shell.
Right, so that you're not losing it.
Exactly.
So, in terms of what are other? You mentioned the refrigerator. What are other things that are operating every day that we could kind of capture, heat with in the summertime to use in the wintertime, or vice versa, like when it's cool out?
Well, actually,
when it's hot out and we want to be cool inside.
Today, it's almost the only thing as a technology that we can use. This combination of solar panels, electrical solar panels, because we have 2 kinds of solar panels that are producing hot water or electricity, and a heat pump that can produce and store some part of that energy. Today, it's the most efficient in terms of economical part. But or to put this energy back to the system. If you produce a lot, you can put it in the system, and then when you need, you can take it from the system. But this is a sort of a rental. I'm renting energy. I'm producing and renting. So by day, I'm doing green energy, but by night, I have to take back energy made from gas, coals, and so on. So it's not a very efficient system, but at least what could we do? It's to take this extra energy and give them to the neighbors. Help the neighbors make their own local energy. And this is the principle how we can become independent. So we won't need the government anymore to help us.
So is this really, are you envisioning or talking about really having much more on a local community level, people getting together and doing this? I just want to go back to the building, the office building for a moment. Yeah. Who funded that? How did you get the money to do that? Because you said certainly in the short term, these buildings are more expensive to build. So how did you get that built?
Well, it was a private owner that had an IT company, and he was growing very fast. And he had 2 problems. One of the problems is that he couldn't find a building big enough for his new team, and he couldn't find a building that should be comfortable enough for his team. Because when you're working all day long on a computer, very fast your legs will get cold because you're just staying, no? Or your back will get cold because you're very stressed, and actually you're putting some extra stress on your body. Therefore, you need to have comfortable condition like temperature, like air temperature, moisture. If the air is too dry, then you have problems with your breathing. If it's too wet, you're sweating. If it's too cold, you are shaking. No, and
I have to say, I'm impressed with the CEO that he was caring a lot about his workers, which,
he was caring,
which you often don't think about as much.
Because he thought that if people have a very comfortable place where to live, they will come with much more pleasure at the office, and they will be much more productive. So he had this business stuff of seeing that people that will work with, for example, if he could manage to have an extra hour of performance in the working period, because we are working 8 hours per day, but actually we are working 4 hours per day. We are productive 4 hours per day. So instead of being productive 4 hours, if you are productive 6 hours, then the company incomes will increase. But also he wanted to make people want to come to their offices, not just waiting to go home because they are very cold or the air is unbreathable and so on. So he knew about this, and he was able to invest 2 times more in this building by doing it as a very comfortable building, instead of because he knew that having this extra money back in this building will he will have them back in about 5 to 7 years because of increasing the performance of the team. So he made all this kind of calculation because he's a very smart guy.
And he has a long-range plan.
A long vision plan. So we've managed to build this building in 9 months. It was a very fast project. He was a little bit skeptical about the energy consumption.
I'm actually amazed that you built it in 9 months. I mean, it took me that long to get my bathroom renovated. You know,
well, it was entirely prefabricated. It was made with the newest technologies possible. The entire pieces of the houses of the building, they were cut by machines and produced with robots. It was the high-end technology of this year. Because do you know what's interesting? We have more technology in our pockets than the first NASA mission into space. When the first rocket get up from the Earth, they were calculating by hand the trajectory. No, and hey, now you just put up your phone and you have everything here. Even the festival is here. No, but still. Sometimes we are building worse than 15 years ago. So in the building industry, there is also a lot of innovation, and it's a lot of new technologies that help us actually build better.
I know it's so frustrating to me when we think about this. You know, on the one hand, the energy crisis has certainly pushed ahead a lot in renewable and sustainable energy, but it's also pumped up the dirtiest kind of fuel. You know, we're digging more coal, we're burning more wood. I mean, it's, you know, it's kind of a step ahead and a step back at the same time.
What I forgot to put on my slides is it's a graphic that shows us how much energy do we use compared with our lifestyle. So when we start to have a more and more comfortable and luxurious lifestyle, then we will use more and more energy, actually. So poor countries use less energy. Rich countries are using a lot of energy due to the luxury part. We have to find an average way to live, to be comfortable, but not to put extra pressure on the entire planet, because we have only one planet. And about this, in the last 50 years, the CO2 level in the atmosphere went up with 100 parts per million. So in the last years, actually, we had the biggest level of carbon dioxide level in the atmosphere. This gas, it's warming up the planet. It's melting the ice from the Iceland and so on. It's raising the level of the sea, and it's making the winters not necessarily warmer, but it affects the natural rhythm of atmosphere. So we have a very big impact on our planet. Sometimes one of my colleagues who's more tougher, he said, like, sometimes we are like the cancer for the planet. We are damaging it too much. So what does actually a cancer does to a body? It kills it.
Mm-hmm.
So if we don't take actions in what we are doing, we also might lose our planet, actually.
Again, I just want to open it up if anyone has a question from the audience. Let's start here in the front, and then that woman over there.
I was thinking, especially for owners of one-family houses, how I think it's very important to build not just energy-efficient housing, but also eco-friendly housing. What are some of the solutions that you would recommend?
Okay, let's just take the
As in natural materials and
let's take the other question, and then we'll give you the opportunity to. And the music is great, but I wonder if we could just close the door a little bit so we can hear better.
Okay, hello. I'm Andrea. My question was, what can we as regular humans or as designers, I'm an interior designer, what can we actually do to promote this kind of thinking? Because I think it's more a way of thinking, more inclusive, and we should actually really think about our planet, because I also think we are a bit a cancer for it.
Exactly.
And what can we actually do to spread this kind of information actively?
Are there any more questions? Go ahead.
You specified that in that high performance building, the cost of heating was €1 per cubic meter.
Square meter of ground.
Yes, but what's the average on a building?
Okay, so let's those are three questions. So the first was about materials, then kind of design thinking, how to get designers, and then the third one.
And I think I didn't answer to the second question that you had, but I'll take them.
Okay.
So all the projects that I'm getting involved in, I'm working with wood. All the structures that I'm building and designing are made in wood, including this office building was made entirely from prefabricated wooden panels. It may look like damaging because we have to take out the wood from the forest, but actually the forest grows continuously. Actually, we need to harvest the forest, not to cut it, but to harvest. Because in the forest, you will have big old trees that will fall anyway. So you have to take those out and use them as material. By fabricating 1 cubic meter of wood as a building material, actually you store 600 kilograms of carbon dioxide. If you produce 1 cubic meter of concrete, you throw into atmosphere about 1 ton of carbon dioxide. So basically, we should use much more natural materials like wood for as building material, wood as an insulating material because they are wood fibers used as insulating materials, and materials that need less energy to be done. For example, fabricating 1 cubic meter of aluminium throws out about 18 tons of CO2 in atmosphere. Use aluminium for a lot of aluminium in sheeting or in elements that are visible or are used in design, for example. I've seen it a lot of copper and aluminium as interior elements that are put it on the walls. It's a high energy consuming. Exactly, or the profile that you put in corners. So we could also use clay. I've used clay. I've also used straw bale. I've managed to do a straw bale school in Romania.
Wow.
Made entirely with straw bales and with volunteers. And it was closed with clay, with earth rendering. It was amazing. It's a lot of manpower there, but it's sort of a traditional and local energy. We could use local materials, not bringing them from 2,000 kilometers away. We're just trying to build up again the local industries. Yes, we should. And actually, grandparents, because our parents started to build big houses in concrete. Our grandparents were building small houses because they were looking around and they were taking the resources that they had.
Yeah.
No? So we should go there back with this.
Now let's move to the design question.
One thing that you could do, and it's what's in your power, it's to understand these principles and to take them forward to your customers, to do education. to educate people, to share the information, to share the principles, and to make people understand what do they should make some choices that probably at the beginning they are not very comfortable with it. For example, you as a designer you mostly are also involved in a project at its beginnings. No, you could advise your client to make a smaller house. He won't need a 300 square meter house because he will have to heat it up. One step. Then encourage people to use better materials, make a better design. You should integrate in your design by working with an architect, better solutions that are also complying with energy performance standards. They are accessible because everything that you've said today, it's accessible. The problem is the knowledge and knowing how to use them. People, for example, are afraid of putting this kind of new technologies because they think they are expensive, but actually they don't. Okay, they are expensive as we are used now. But for example, heating ventilation and recovery system, it's about 5,000 euro. But if you take the energy that it saves, you will buy it back in 7 years. Right. For example, to put an extra insulation on a house, it may cost you 10,000 euro, but you have a 2,000 euro bill on each winter.
Every year. Right?
Every year. So this you will buy it back, and then from that moment when you've bought it back, you will go on economy. You will be more economical with your building.
Right.
And there was
the third question.
Third question. I think it would be helpful to remember it.
You said it cost €1 per cubic meter.
Okay. So 1 euro per square meter. We calculate the energy cost considering each square meter that you can use in order to compare my house to your house or with your house. Well, they had average cost of 50 euros per square meter in the past years, when we didn't have this problem with the gas price that is going up. So for them it was amazing. They couldn't believe, because we've mounted sensors and contours on each equipment. So we've managed to see how much energy is used by the heating system and how much energy is used by computers. They were using 60% of the energy of the building was by computers and servers. But the idea is that we've managed to take out the heat from them and give it back to the building, actually. No? Because either way, you will use a computer if you are working, even as being in an IT industry.
Right.
So they were shocked, actually. Therefore, we are building for them. We are designing now for them the second building, which is for 700 people, with these principles.
So
it's nearby Oradea. It's not in Bucharest. It's in Oradea.
So I have to say, I came from another conference before this, and almost every panel I've moderated, I've ended up feeling much more pessimistic than I had when I began it. And it was nice to hear something inspiring here, Marius. So thank you so much. There's lunch next after this in the garden, so please join us for that. And thank you all so much for coming.
Thank you very much.
Yeah, I'm sorry, did you want to say one more thing? One moment.
So one last word I want to say. We were born, or we've grown up in houses that were consuming a lot of gas. We live in houses that are consuming some gas. So we should live and build in passive solar houses.
That will produce.
That will produce energy. Thank you.
Okay. Thank you all.